Okay, chapter 8, right? It's about your waves lah, huh? Especially we actually focus on radio waves, or we should say electromagnetic waves. Okay, so generally all waves are continuous oscillating movement because wave goes up and down. No matter what wave, sound wave, light wave, radio wave, the C waves, all waves works the same principle, which is oscillating movement, means back and forth. Okay, back and forth, right? Propagate through the space. Yeah. If you don't like to write the word propagate, then you might write travel, or if you think propagate is a bit difficult for you. Okay, so all wave generated through vibration. Okay, regardless what kind of wave, all waves works the same. Okay, right, these are the structures of waves that you have to understand. Okay, quick reminder to everyone. So wave, you have displacement versus distance graph, or sometimes you might have displacement versus time graph. It depends. Okay, so first thing first, what is a wavelength? Wavelength means the distance between two waves. So this is the wavelength. Now, wavelength is actually about the length, by the way. It's about the length. It's not like it's not really like a labeling, you know. What I mean by that is if you see, I can actually move this to like other area. This is also wavelength. Same length. If this is 10 cm, here is also 10 cm. 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 It's 10 cm anyways. You understand? It's about the number. So wavelength. But if labeling, it will be here lah, but rarely they ask label one. They want to know the number instead. Yeah, labeling. Okay, that's first one, wavelength. Yeah. Number two, frequency. Frequency is basically like a calculation, I would say. How many complete wave in 1 second? That's what frequency means. Okay, how frequent, you know, like we will say, wow, the frequency of this guy coming to the activity very high, means this person attends the activity a lot of time. That's called frequency. So how many wave in 1 second? How many attendance in a month, for example, if we're talking about the example just now. Yeah, so 1 second, how many waves? Now, one wave means 1s. You understand? So if let's say this is 1 second, right? I have 2 s's. Okay, can that will be 2 hertz lah. Can okay, so that's the meaning of frequency. Unit in hertz, by the way, Hz. Okay, amplitude. Amplitude is how tall is the mountain, how tall is the wave, which is given here lah. Graph will give you lah 5 cm or whatsoever. Okay. Monisha, which one? You mean frequency? Okay, so frequency, 1 second, how many complete wave? First of all, what is complete wave? Complete wave means 1s. Okay, so if I say this is 1 second, how many complete waves do I have? I have 1, I have 2 in 1 second, let's say. So this will be 2 hertz, which is 2 frequency. Okay, since we're talking about this, right, a bit of calculation for you guys. Okay, let's say if this is 0, okay, this is 0.1 second, this is 0.2 second. Okay, my question now, everyone, you all make sure you all get this. My question now is, what is the frequency of this wave? Frequency of this wave. Let me remind you again. Frequency means how many waves in 1 second. In 1 second. get second, 1 second. Okay, give me a number to see if you understand. 1 second. It rhymes. Obviously, I didn't give you 1 second. If I give you 1 second, why I ask you all answer already, ma? I didn't give you 1 second. The information that I gave was one wave takes about 0.1 second. So if I were to extend this to 1 second, how many waves would I have? Jajun, correct. Correct answer. How about the rest? You all get this? Monisha, are you? Oh? Okay, I'm surprised that you guys got the same thing. Okay. How about the rest? You okay? Now, if one wave is 0.1, then 1 second, how many waves? 10 waves, right? How many S until it reaches 1 second, right? You get it? So 1 wave, 0.1. 2 wave, 0.2 second, 0.3 second, 0.4 second, 0.5 second, 0.6, 0.7, 0.8, 0.9, 1.0. I will have 10 waves in total. You'll get it, especially Monisha and Ashara, do you get it? The rest, I'm not too sure if you get it, but basically that's how. Okay? Can Monisha and Ashara, okay? Monisha, you okay? Okay. So I did not give you 1 second, right? I give you maximum 0.2 second, right? No worries. Okay, just to make sure you understand this. Okay, so one wave is 0.1 second. But frequency doesn't count with 0.1 second. Frequency goes with 1 full second, right? Okay, so let's say I know I have 1 10-cent coin now. Okay, I want to know that 1 ringgit RM1 is how many coins? 1 coin is 10 cents. How many coins I need to accumulate in order to get 1 ringgit? 10 coins, right? So I would have, what is this 10 coin? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 coins to form 1 ringgit. Yeah. Okay. So I would like to know 1 second, how many waves, how many hertz? Where I know 1 hertz, I have no space to write. 1 hertz is, wait, let me move this away. Where I know 1 hertz is 0.2 second. Okay, so Monisha, how many waves do I get in 1 second? If 1 wave is 0.2 second. So, yeah, you get it. Now I'm changing the number if you realize. Okay, I'm changing. So Monisha, tell me what's your number. Let's say I'm changing the number now actually. Diva, you are correct. So Monisha is not 10 now. I'm changing number, do you realize? If 1 wave is 0.2 second, how many waves would I get in 1 second? So if I have 1 coin of 20 cents, how many coin would I get into 1 ringgit? There you go. Correct. Okay, 5 hertz. You're okay with that? I'm not sure if my explanation is good enough, but I hope that helps. So yeah, no problem, everyone. Can question wouldn't give you 1 second one. Give you 1 second, then give you answer already, right? 1 second, 10 waves, right? Then my answer already, but they won't draw 1 second one. 1 second is very long, so they draw like 1 or 2 wave, but not 1 second, lesser than 1 second one. Then you have to add up in order to find out 1 second. So if you're confused, you use the money method lah. That's how I think it works better. How many coins do I need to accumulate to get 1 ringgit? Yeah, is everyone okay? Righty, so that's frequency lah, basically. Okay, now amplitude. Amplitude, the mountain how high, no problem. That one is from your graph one, so easily, like wavelength like that from your graph one. Frequency requires a bit calculation. Yeah? Velocity is also calculation. Velocity is frequency times wavelength. Okay, frequency times wavelength, which your answer is given lah. You have to find out wavelength and frequency, then you do the maths, then you get the answer. Is that all right? Okay, so that's basically the first part. Yeah. Okay, then we focused on electromagnetic wave because there's so many waves out there. There is sound wave, there is light wave, there is sea wave, there is human waves. There's so many waves. So let's focus on electromagnetic waves, which are waves with electrical and magnetic property. Okay, which include all this stuff. You all got to remember the sequence a bit. Left and right doesn't matter. Left and right doesn't matter. It can terbalik one, but the sequence must follow. Okay, gamma can start here, gamma can start here also. Question can terbalik and confuse you, right? So make sure you follow exactly the sequence. Okay, so gamma, X-ray, ultraviolet, visible, infrared, microwave, television, radio. What we really want to focus on is the last 3. Okay, which is for communication use. So microwave, television, and radio, all together we could call them as radio wave as well. Is that all right? Okay, so different waves have different wavelength and frequency. Different waves have different wavelength and frequency. Okay, so on the left side for this time, you have higher frequency, shorter wavelength, because in 1 second, let's say this is 1 second, there is a lot of wave. But when there is a lot of wave, the distance between the 2 waves is shorter. It's like that one. When the class a lot students squeeze together, means no distance already one. Your shoulder to shoulder is just next to each other. You understand? Shoulder to shoulder is next to each other when you have a lot student in one class. But on the other side, in 1 second, you have probably only 2 students. The distance between their shoulder are far away. That's long wavelength, low frequency. Make sure you understand how it works. Everyone okay? Yeah. So must also know how to see lah. Like look at the wave, then you probably know. Okay, this is low frequency. This is longer wavelength. Can? Okay. So the characteristics. Yeah. All electromagnetic waves fulfill this 4 characteristics, but I will choose 2 very important for you, which is travel the speed of light and can travel through vacuum. All electromagnetic wave, especially I'm talking about the 3 that we want to focus on, which is the microwave, television wave, and radio wave. Okay, it travels at speed of light, which is 3 times 10 power of 8 meter per second, which is also translate to 300,000 kilometer per second. If to translate to something you can understand, means if you run as fast as light, you can travel the Earth around in 7.5 rounds 1 second. That means if I could run as fast as light, I could go, guys, I'm back. I've gone 7.6 rounds. Very tired. Wow, that was fast. In 1 second. You know what I mean? So yeah, like flash. Okay. So Can travel through vacuum. That's very important because that helps us to transfer wave to the satellite on the outer space for a communication, and so those are two very important uh, criteria or the characteristics we have. Okay, so like I think we can try out number one. So please turn with me to what page is this? 32, page number one. Okay, can right. A1, A2, and B for you. Now you try. Very easy, straightforward that we have mentioned just now. Right, no problem. So amplitude is which alphabet? Amplitude is how tall is the mountain now, W. Yeah. Wavelength is the distance, wavelength is the distance between the two wave, which is X. Yeah. And B, if the wavelength is 2 meter, frequency is 150 hertz. What is the velocity? Calculation formula is in front. So velocity equals to frequency times wavelength, frequency times lambda. There you go, frequency times wavelength. Okay, so very simple. Frequency is, okay, I'm just gonna continue here. So frequency is 150. But when we come to calculation now, we're not gonna use hertz, we are using per second. Okay, per second. Yeah, times 2 meter. Okay, very easy. If you're wondering why do we change to the per second, because that formula is given, I mean the unit is given here. Okay, can. So when single unit, we write hertz. When we have calculation, we go for per second, because per second per second right? 1 second How many waves in 1 second? 1 second per second. Okay, there you go. Right, next, please fill up X and Y. You all have to remember the sequence. Okay, can you do it now? Then we will arrange the frequencies. Okay, so X will be X-ray, Y will be microwave. So if you're wondering, radio ma TV me, later the next one is TV. But then where's microwave? So microwave is between law. So in this case, we would rather call this as microwave, and we would call the radio wave as TV and radio combined. Okay, TV and radio combined. Can? Alrighty, so next one, arrange the radio waves. Radio wave means TV, TV, radio, and microwave all together. All the three behind, it's called radio wave. Yeah, you see this radio wave. Okay, in increasing velocity. Okay, like this applies your basic. You all know increasing velocity means starting with low velocity. Increasing frequency means starting with low frequency to high frequency. So which one has low frequency? When we say low frequency, basically means longer wavelength, right? Low frequency means lesser student. Yeah, lesser student means shoulder to shoulder has longer wavelength. So low frequency should have long wavelength. Yeah, longer wavelength. So we should start with LW. Okay, so LW to next one will be increasing frequency, means the wavelength also becomes shorter, right? So MW. Okay, medium waves, and then followed by short wave. Short wave means what? Means the wavelength is very short. Short wave means high frequency. Then followed by you know how to differentiate very and ultra, right? Okay, so very high frequency. Okay, followed by ultra high frequency. Okay, no problem, everybody. You'll get it. Monisha, okay? Because you say SW the first one, right? Starting with long wave first. That's basically means low frequency, long wavelength. All right, cool. Next one. State two property of microwave. Okay, doesn't matter microwave or whatever wave, as long as you're in this, you share the same characteristics. So like everyone, that's for you. Number A and number B lah. All right, next one, shall we? State other use of microwave. Okay, I believe everyone first learned and heard about microwave is the cooking microwave machine. Then only you come to this one. Wait, why cooking and this one? Actually, microwave was for all this. Then we invented microwave oven. Okay, so anyway, your answer is to cook food. Okay, to cook food. Alrighty. Okay, the next page, right? Especially this part, you all read then can not too, not a super important one, okay? But at least just now you all know how to arrange out there. Long, medium, short, VHF, UHF, and microwave. Yeah, that's the part that we've been doing just now. So make sure you all know how to arrange in sequence and roughly read through like their uses. So the first three is radio. The second, the third, and the second and the third. No, I mean the fourth and the fifth is for television. Yeah, and the last one is microwave. Do you realize that the three columns that I draw to you is basically this tree in increasing frequency? All right, so we have long, medium, short, VHF, UHF, and we have microwave. Read that, yeah? And this also spend some time on reading as well, especially the drawing, must know, and also what are they for in radio system. I'll come back if I need to later when we do exercise, because we are getting into the next part, radio transmission system. Okay? Okay, so radio transmission system is the system where on the DJ side, so the DJ would sit in the studio and speak to the mic, and we'll be able to listen on our radio. But how does that work? On their side, they have a transmission system. On our side, your phone, your car, or whatsoever, you have a receiver system. So let's talk about transmission system. First, the DJ talks to the microphone. So the job of the microphone is to change sound wave into electrical signal. Change sound, which is what your ear can hear, into electrical signal, which is suitable for the computer to store as information. There is no sound. We would store it in like a wave form, like when you see people creating sound with the computer, there is a lot of waves. Those are called electrical signal because that's better to transmit to the other areas rather than the human voice. Do you understand what is electrical signal? You get it? That's the job of the microphone. Okay. Once it is in electrical signal, oscillator will produce radio waves. Radio wave is like a driver to tumpang my electrical signal out, because my electrical signal cannot travel, no leg, how to walk. no leg, how to walk? We need to have something that can transport my electrical signal, yeah, which is called a radio wave, which is this one, my friends. You get it? Yeah, this is the wave that helps my electrical signal to transfer to other area. Okay, so once I have my electrical signal ready, I have my radio wave ready, we both combine them in modulator, which is the function to combine electrical signal, which is also what we call as audio signals, with radio waves, which is the driver, called the modulation process. That's how we combine them together. Huh? Okay, once they have combined, we now call the wave as modulated. Why? Past tense, modulated audio signal. Basically means audio plus radio. Audio plus radio waves. Okay, so we will strengthen the waves by amplifiers so it can travel further. We send to transmitting area and boom, send out to the atmosphere. Is that all right? Everyone okay with this? So you have to kind of memorize the steps, then can liao, and also the function lah. We will come back if we need to. Please come with me to page 34. Yeah, we'll do this. Question 3, page 34. Okay, right. I think question A and B for you now, very easy. I've just talked about it just now. Okay, A and B, yeah, everyone, for you. Okay, so P is microphone. You'll be like, why microphone on top one? Never mind, doesn't matter. It's okay. Oscillator is here, then my microphone doesn't matter. No sequence you don't have to be, oh, this one die must oscillator, or this one die must microphone. Okay, so that's fine. And Q will be amplifier. That's it, easy cheesy. Function of Q, you copy from here, right? But you have to do ayat song sang, I think. You have to write to amplifier is to strengthen the modulated audio signal. Yeah, if you write like that, a bit weird in grammar, like or sentence structure. So no problem. Mark the correct component used in part Q. What is part Q? Amplifier. Which electrical component in amplifier? Okay, this is when this thing comes in picture. Okay, you got to find out which component used in amplifier. Okay, yeah, this part like very small like 1 mark. Oh, if you ask me, need to memorize. If I say need to memorize but no come out, you also angry me, right? If I say no need memorize but come out, you also angry me, right? So how you all think about it, huh? So I would say you could roughly read through. So do you all find that already? Which component involved in amplifier? Look through the whole list. You'll be able to find which is transistor. Okay, transistor. Amplifier uses transistor. There you go. Like that lor. Okay. Can must kind of read through that table also lah. Must know what component in which area, which part. Okay. Right. Question D. Draw a wave pattern after passing through Q. Draw wave after passing through Q. Q is amplifier. Draw wave after passing through Q. Means draw amplitude modulation. Wait, let me show you. This one. Modulated audio signal. After amplifier go out, right? The wave is called modulated audio signal. So which one to draw? We draw AM. Rarely we need to draw FM1 unless question asks for it, or else if it's not stated, we would draw amplitude modulation rather than frequency modulation. Okay, so we are going to draw this. I'm going to show you one time. This is how we draw. Okay, you will create like spectacles. Okay, something like that. Then you will try to join bottom to top, bottom to top. So the top and bottom works like a frame, you know, for you to draw within. Don't draw out of it. Don't draw too small within, but touch up, touch down, touch up, touch down, touch up, touch down, like that. There you go. That's how you draw a AM or from radio lah. We always draw this one. Rarely we need to draw the FM unless there are some, but I think we probably don't need to draw AM at all. Okay, this is from modulated audio waves. This is how we draw it. Okay, can. Alrighty. So remember, draw AM, confirm draw AM one. Unless they mention FM, then you draw FM. How to draw FM? Very easy one. FM is frequency, not up and down. Amplitude modulation go amplitude one more, up and down. For frequency, you don't draw up and down. We draw a fixed cage or a fixed like a frame. Yeah, and this is the center part. Okay, then we would just go for like that. You know, we go for, okay lah, my drawing is very bad actually, sorry. We go for like a lot of waves, very little waves, or very little waves, you know. We don't go tall and short. We go more wave or less wave, which is frequency. Yeah, that's basically how to draw. But anyway, we don't need this now. Okay, state the energy change in P. State the energy change in P. What is P? There you go. A microphone energy change. Okay, we don't learn this in front, but it's pretty basic, I guess. Like when you speak to microphone, right? You speak with your voice, right? So that has to be sound energy. Okay, change into, so the job of microphone, right, is to change sound into electrical. Yes, that's correct, Shara. Alrighty, can? Ding, there you go. Okay, very easy one lah. Can? Okay, like receiver our side. Do you all still listen to radio? I don't remember when's the last time I listened to radio. Since now we have so many social media, we have so many platforms to listen to songs. Radio is like, you know, getting like outdated already. So first we have a receiver, regardless your phone, your car, or your radio systems at home, you have a receiver to receive signal, which is to receive the modulated audio waves from transmission system, right? Then you have a tuner circuit. Tuner circuit is to choose the signal that you want to listen to. Yeah, let's say you want to listen to hits.fm 92.9. Then, oh yeah, you change to 92.9. Then tuner will choose for you, lor. Okay, and tuner contain inductor and capacitor. There you go. This is where all the electronic comes out now. You have to remember them. Okay, inductor and capacitor. Okay, pass to detector circuit. Detector circuit basically is the opposite of modulator. Yeah, opposite of modulator. Modulator is to combine electrical signal in the computer together with the driver. Okay, to travel 7 seas and throughout the whole planet Earth. And then when it arrives to our radio system, our detector circuit will separate the electronic signal, or we call the audio signal, from the driver. Make sure they separate. Okay. For example, if you want to go somewhere, you ask for Grab. Grab come and pick you up to travel, right? But when you arrive, does the Grab like go with you, or the Grab will go home or go away from you, right? So we want to separate the audio from the driver. The driver throw away, no use one. It's just a form of transportation through the air, or else how do you expect my sound or my voice to travel, right? So we need a we need a transporter to actually travel the sound. And then it's called demodulation process, which is the opposite of modulation process. Demodulation process consists of diode and capacitor. So we have both capacitor here, capacitor here, capacitor here. Okay, can? And we have extra diode just in case. But both capacitor, remember? Okay, so then detector circuit will transfer the electrical signal. It is still in computer. It's all like sound wave, like waves in the screen. There is no sound yet. We have to transfer to amplifier to make it stronger, because the audio has been traveled 7 seas and throughout the whole universe. It's a long journey. It loses energy. We would need to amplify the energy. And it consists of transistor. Remember just now that question? Just now there's one question asking for where? This one, right? In Q is amplifier ma? Amplifier got transistor. You know who's transistor? The sister of transformer. Transistor, okay? Which is your amplifier to amplify the electrical signal. Okay, like you want to like kill me already, right? With the stuff. So then, lastly, then the electrical signal sends to the loudspeaker. Loudspeaker will change the electrical signal into sound that you can hear with your ear. Ladies and gentlemen, welcome to Fly FM. So what you've been listening all the while, like now, even right now, it works the same way. I mean, you think about it, right? From my side, right? I'm talking to my webcam and the microphone. I'm using my sound energy to speak, but the microphone changes my sound into electrical signal. Don't kill me. Okay, so then it will store in my computer, and my computer will send the signal to the internet. And then when the internet reach your house, you have the internet in your computer or your phone. And then the information will be translated by your speaker, your earphone, or whichever way you're listening to me now, and change it to sound again. Do you get it? Okay, no problem. So basically, a lot of things uses this kind of system one. Very similar, no matter radio or not radio, like now also. Can? Okay, like we try the question. You turn with me. Please turn with me. People, let's turn to this one. Very annoying, the car side, the car alarm. Can you hear? I think you're here, right? Beep. I think I want to do question 536. Question 536. So annoying. I'll bomb the car later. Okay, like number 5. For you, question A1, A2. Like for you, everybody. Oh, come on. So annoying. A1, A2 for you. I go bomb the car first with me. I'm back. No more, right? Because I bombed the car. Okay, so component K. This is a receiver, right? So this is aerial to tuner circuit K. Function of loudspeaker. You copy from the front. Changes sound energy. Changes audio signal into audio wave or sound again, right? You copy from the front, exactly, right? Next one, diagram below shows a symbol. Where can be found? Which component in diagram above use this electronic component? You have to remember the diagram though. Let's check. That is your transistor again. Okay, this is transistor. Where do we use? We use that in amplifier, remember? So which component in diagram that uses this? Of course, that is your amplifier. This one, correct. Monisha. So yeah, like your answer is amplifier lah. Okay, no problem. Alrighty, next one. The radio receive modulated radio wave. Okay, when you see this modulated radio wave, basically means AM. You're required to draw again. Nah, let's not waste time. You know lah. Draw this, okay. I'll leave that to you. Question D, your body. Okay, diagram below shows the electronic component used in. Do you remember? Tuner uses capacitor and inductor, correct? Detector circuit uses capacitor and diode, correct? Okay, anyway, two weakness of the radio. Wow, this is a bit challenging. Now, first thing first, do you realize there's something missing here? We have aerial, tuner circuit, detector circuit, and that's true. We lost speaker, man. Something is missing. Something is missing. What is that? Something is missing here. So if you have already memorized, you know the sequence, you used to it, you know that amplifier is missing. Correct. Because in Malaysia, right? Amplifier is there. So straight away, I know one weakness already. If the amplifier is missing, I means the electrical signal is gonna be very soft. The signal is very weak. Right? So when the signal is so weak, where you don't have this to actually increase the signal, right? The loudspeaker wouldn't like give you any songs or any sound, but probably very soft lah. So that's the first weakness that we can think of, yeah, which is weak audio signal. All right, weak audio signal. Okay, like this is how you write. Boom. Weakness number one. Okay, weak audio signal is passed to the loudspeaker. Okay. So second weakness, this is a bit the deep one. You realize capacitor is here. Okay, but we don't use fixed capacitor. You know why? Let me show you. Okay, you all see this? We use variable in radio tuner to pick up audio signal from transmitting station. We don't use fixed one. Fixed is not in the radio system. So we use variable one. So if we use fixed, what happened? That means we cannot choose station. Now you can choose one. You want Fly FM, you must choose Fly FM. You want History FM, you must choose. So now it's digital. We don't really choose. Last time really have to choose one. Last time we had to turn the knob, the old school one. You have to like change that pointer. But now it's digital, it's auto, So this plays a very important, sorry, my slang sometimes comes up. Important, everybody, the important of the variable capacitor. That is for us to choose the correct station. No? So the second weakness will be you cannot choose. You'll be listening to, like when you buy radio, right? There is so many different radios with only one station. You can only choose that. Oh, you want to listen to Fly FM? Oh, that one. Oh, you want to listen to History FM? Oh, that one. So the weakness will be you'll be only receiving from one particular radio station only. All right, that's the two weaknesses we have. Okay. Okay, I want to do question 6 with you, although this is not like a very, like a rare, this is considered a rare question, but just in case, so I'm just gonna go through the electronics with you, which is here as well. Electronics looks like that. This is a receiver. We only learn about receiver, receiver, which is our side, your phone, your radio, whatever. Okay, so first things first, what is the function of detecting circuit? Okay, detecting circuit. Well, from here, by the way. Okay, no problem. So go ahead, everybody, to separate audio signal from radio. So it would ask something out of this part also lah. Then suddenly they will ask like function of detector circuit, although it's not a picture of the whole sequence that we had just now. It's electronic components. All good? Alrighty. Okay, next one. Label transistor. Oh, the third time we have talked about the sister of the transformer. So do you remember the picture? This is the second or third time we have seen the picture. So this one, this one transistor. Okay, there you go. Draw the symbol of electronic component that is missing. What is missing? This is missing. What is that? That is called the diode on the top. Yeah, diode. You have to draw this picture. So there you go. Okay, diode. Diode. Must name them as well. I remember. Okay, all good. Right, next one. D. Name the circuit that choose frequency. So easy. The circuit that choose frequency, of course, is the tuner circuit. Okay, tuner. That's for you to choose your frequency. All right. E. Draw the amplitude modulation. There, AM. Again, lazy. I don't want to draw. You draw yourself or don't draw. Same thing. Then you draw the up, down, up, down, up, down. Okay. Amplitude modulation. Yeah. Either they will say this amplitude modulation or they will say modulated audio signal. Then you must know it's the same thing as AM. Unless they say specifically FM, frequency modulation, then only you draw FM. Okay, what is the energy change in speaker? Oh my God, so easy. Speaker, you know, your earphone now, or your phone now, or your computer speaker now, what's the energy change? It is from computer to something your ear can hear. So that's electrical signal to sound, electrical energy, sorry, I meant electrical energy to sound energy. Nice. Okay. Yay, we are done, everybody. Finally, all of your chapters, okay, we're done for the night. I'll see you next week with the new material you should be getting soon, okay? So see ya, everybody. Have a good weekend.